Just a second here. Alrighty. Happy Monday. Hopefully this goes a little smoother than earlier Monday did, but we'll see. See how that goes. I had myself on mute in OBS for like the first couple minutes, so that was fun. I didn't use the mute button this time because, oh dear. All right, so we are here in week 3. We pretty much covered all of chapter 2 right on Wednesday. Right? I know it was like a week ago, almost a week ago, but so we're moving on to types, which is good. We want enough time to talk about types, and then we'll get into Project Zero probably on Wednesday. I don't think we'll get enough into types today to have enough for the project. So we'll do starting with types today, and then we have our lab after class where we'll do practice with variables and expressions, and some types. We'll see how far we get, and then on Wednesday, we'll finish up types, talk about the project. So I expect that to be due probably the 28th then. So every project will have 2 weeks to work on. So we'll probably end up doing projects on Wednesdays. And I think that'll work out nice because otherwise we've got like the lab on Monday and that might be funny. So I think that'll work out. Hey, thanks for joining online, Indevity. Nice to have you. All right, so talking about different types in Python. So far we have done integers, we've done floats, and we've done strings. That's about it so far, right? So we can get some string input, we can convert it to integers or floats. If we want numbers with decimal places, we use floats. If we want whole numbers, we use integers. And that's about it. So let me fire up PyCharm here. I'll start a new project. This is week 3 already, my goodness. We are just cruising. Do a new project. Make sure it's in my GitHub repository folder, which is great. And then we'll call this week 3 types. Create our project, and we're off to the races. All right, we can clear out all the starter stuff. Right. So for integers, right, we just give it a whole number. That was easy, right? Some number is 10, right? Float, numbers of decimal places. Some number with a decimal, like 15.6. Sure. Some string. You just use quotes, either single quotes or double quotes, or the fancy triple quote. If you want to use a multi-line string, you could use the raw string option, right? We talked a couple different ways of using strings last chapter. Python doesn't care. They're all strings, right? So anyway you want to have it here, we just have some text here in quotes or single quotes, or raw, or yada, 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 yada. Okay, got some options. Those were the basic types we started with. Now, we're going to look at more interesting types here. So we did strings. There are lists and tuples and sets and dictionaries and binary numbers. The string formatting we'll get to. So lists and tuples are very similar in Python. So a Python list is just a list of things, right? Just like if you were to make a list of something, it's just a list. You can add stuff to your list. You can take stuff off your list. You can add something to the middle of your list if you want. That it might be a little bit harder for you to, like, if you wrote it all down, you know, either like write it between the lines or have to erase everything and bump it all down and put stuff in, but it's functional. We can add stuff to it. We can subtract stuff from it. So we have some list. Then in Python, we use these square braces here. So empty square braces is an empty list. If I want to put things in it, I just need to comma separate them. Just like when you print, you can comma separate and print as many things as you want. With a list, we can put as many things as we want in here. So if I wanted to have a list of names, so if I list out all my kids, I have Joy. It's her birthday today. Everyone should wish Joy a happy birthday. I don't think she usually watches my streams because they're terribly boring for her, but she has Twitch on her iPad, so like she can watch if she wants to. I'm like, did you watch me teach? She's like, no, Dad. Like, why not? Isn't it fun? No, Dad. She doesn't think I'm funny. You guys think I'm funny, though. I appreciate you laughing at my jokes. That is fantastic. It makes me feel good. We got Joy. I have Jeb, or Jebriel, if you want his full name, here. He sometimes watches and is trying to learn Java. He's 14, about to turn 15. Joy's turning 21 today, which is crazy. I have a 21-year-old, but it's another story. So Jeb's almost 15. I'm trying to teach him how to code, and like he's sort of interested in it, and then he gives up. Like, come on, you can like follow along on Twitch or on YouTube. It's like, take a free college class. He's like, no, Dad. So I'm 0 for 2. 0 for 2. Right, and then I have a Genevieve, or she goes by Vivi, but it's also spelled with a J. So Genevieve, V-I-E-V-E. I can spell my kids' names, I promise. So I got Genevieve, and again, I'm just comma separating. So I'm just putting a bunch of strings in here. Great. And then I have Journey. Genevieve is 13. Journey is 12. I remember all of these, I promise. And I have Jubilee. She's 10. Then I have Jackson. Usually we call him Jack. He is just turned 8. And then the new little guy, Jasper. Oh, I'm going on a little too far. Let me bump some of these down the line here. Jasper is 7 weeks and a day. So got quite the range. But that's a list of my kids. It's a lot of fun. Maybe it shouldn't be some list. This is Eric's kids here. And really, it's their names specifically here. Eric's kids' names. Sure. This is just a list of values. Is there a question?
Yes. Does it matter if you do the double quotes or the?
Nope. So they're all strings. Yep. Yeah. And any way you want to make them. And I could do raw strings in here. I could do the triple quoted strings in here. They're all strings to Python. Python doesn't care much. Right. So if I wanted to print my kids' names here, I can just hit print, and I get back out basically exactly what I put in, which is pretty cool, except it's all single quotes. Sure. Right. Why not? So it gives you the list indicator with those square braces that it's a list, right? So you'll see that if you try and print them out. Now, things we can do with lists, and I want to make sure we don't get too far because there's a whole chapter on lists later that we'll get into, but I don't want to go too far. Let's take a look at some of the basics real fast, make sure we're not missing anything. Making lists, accessing the items here. There we go. We'll get to that. Updating, adding or removing. Great, yeah, a whole bunch of fun things we can do with lists. And that's the basics, cool. So to get at individual items in the list, lists are things in which the order matters. So the order does matter in a list, right? So the first thing in the list will always be the first thing in the list unless I move it around or put something, make a new first thing in the list. So to get at things, just if I want an individual item here, we use something known as the index. So the index of an item in the list is where is it in the list? Is it the first thing? Is it the second thing? Is it the third thing? Is it the fourth thing? Now, the fun thing about Python and basically all programming languages, except for like one of them that irritate me, is that the first item is not index 1. Right? The first item in a list is index 0. So we can access individual items by index. So I would say if I wanted to get just Joy's name here, it's Eric's kids, and then I'm going to use that square brace notation again. I want to say index of 0. So using index value, something, index number, something in here. So this will get out the 0th item, the first item here. So this will print out Joy for me. And we can say, happy birthday, Joy. Happy birthday. And we'll just comma separate. And now we get happy birthday, Joy, because that's the first item in the list. Now, the reason why it's 0, when we make a list of things, Python goes out to the operating system and says, hey, I need a big chunk of memory to store a bunch of things, right? When we said, hey, I need to store a 10, Python goes out and says, hey, operating system, I need 4 bytes. That's all I need, just 4 bytes. Just give me 4. Right? If we're storing a floating point number, I think it was 8. Python says, hey, I need 8 bytes, just 8. When we store a list, it's like, I need a bunch of spaces here because I'm going to store a bunch of stuff. What goes into each of these values then is actually the location of where the actual value is stored. So remember we talked about memory and memory addresses and everything is done in binary, and we say, hey, I have something out of memory over here at x27, I have something over here at x59. They're like big long hexadecimal numbers, just reasons. The list then is nothing but here's the first memory address, here's the second memory address, here's the third memory address, here's the fourth memory address, here's the fifth memory address, here's the sixth memory address, on and on and on and on. And in a 64-bit system, each of those memory addresses are 8 bytes, 64 bits worth, basically. Don't worry too much. Take a low level class if that sort of thing is interesting for you. Not that it's not good stuff to know, but so the first value then is at the location of the list in memory, offset by nothing. So what happens? I can kind of sketch this out here. I forgot to bring my style or my big pad again. Should really bring that because it's a lot of fun. So if you were to imagine a list here then in Python, and we get the first thing, the second thing, the third thing, the fourth thing, this is just a memory address, like 23. Somewhere out N23 in memory is the string Joy, right? The next thing out here, I don't care where it is, it's just some memory address. Maybe it's 92. So somewhere else out of memory, then we've got Jeb, right? But inside the list, then it's just 7 memory addresses in my case, right? So the first memory address, the second memory address, the third memory address, on and on and on. So the sum list here, what value that sum list stores is the memory address of where this starts storing other memory addresses in memory. It feels a little crazy, but it makes a lot of sense if we think about it for a minute. So what a list stores is just a bunch of other addresses. Okay, where's the first thing? Where's the second thing? Where's the third thing? Where's the fourth thing? So if variables, if all they're doing is storing where something is in memory, right? A list stores where the list starts. Where does the list start storing things in memory? I'm going to have so many slots for memory. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over here at the College of Engineering and Computer Science at University of Michigan Dearborn. That wasn't so bad all in one breath. I'm getting faster at saying that. Bless you. That is so cool of you dropping by. Appreciate that. So the first item then, so this entire list might be stored at, say, x72. Right? The first value here is 72 plus 0. The next value here at index 1 is 72 plus 64 bits, or 8 more bytes. This value over here at index 2, right, index 0, index 1, index 2, is 72, right, x72 plus 64, 4 times 2. So 2 times the size of a memory address ahead of the start of 72. The thing at index 127 is 127 chunks of memory addresses, 127 times 64, ahead of 72. It's just simple arithmetic that the computer's really good and fast at doing, and I can get at the 127th item. I can get at the 900th item. Right? Any index I give it, it just does some quick arithmetic and goes and finds that offset to find out, okay, where is the memory address I need to go look at? And maybe that then is, x19 or something. And again, these are really big numbers. There's billions of bytes of memory in your system, right? Remember, a byte is just one, and then your kilobyte's 1,000 bytes. The megabyte is 1,000 kilobytes, a million bytes, and then a gigabyte is a billion bytes, and we have multiple gigabytes of memory. So you have like 64 billion bytes of memory or something like that. Maybe I only have 32, so 32 billion bytes of memory in this system. Sure. So we can store a lot of values out here. But we start at index 0 because there's no offset. You want the first item. You want the beginning of the list. Hopefully that's helpful in remembering why we start with 0. It's a little annoying that we always start with 0, but that's how that works. Okay? Now, with the list, now this will get the value out. You can also go and set the value if you want. So Eric's kid's name's at index of 0. So usually I'll read this as at when I see these square braces. I'll say here's some list at index of something. That's just how I read it out loud. We're just using those square braces to say index of. It's just a way of reading it. You can assign a value to a particular location. So Joy, what do we want to do? Let's make her name all uppercase here because we want to shout her name for her birthday. She loves when I'm really loud. It drives her crazy. So of course I do it a lot because it entertains me as a dad. So now when I print happy birthday, Eric's kid's name's index of 0, I should get the all uppercase version of Joy. So it starts out lowercase. We change the value at this location here. So he said, okay, hey, Python, the list that you have, that first thing you're storing, don't store this memory address anymore. He said, hey, forget x23, put Joy and all uppercase in memory somewhere. Maybe at, I don't know, let's call that x42. Right, so we changed the value that was stored in the list. And the value that's stored in the list is a memory address of where this new string is in memory. Strings have this funny property of being it's known as immutable. You can't technically change a string. You just make a new version of it in memory.
This may be a stupid question, but in a list, the memory slots are not consecutive.
They are consecutive, yeah. So the list in Python will grab one big chunk of memory. That way it can do this offset notation. The values that are stored inside of the list are not consecutive. So my strings can be all over the place in memory. But the list itself, if I have 10 memory addresses, I'll have 10 64-bit chunks all in a row. Because those need to be consecutive in memory for me to do that offset notation to say, hey, go read the thing at index 19. All right, 19 times the size of memory address plus the start. Here's where that thing is. Here's that value.
So how does x42 correspond to x92?
So 42 is where the new string is stored in memory. So the values inside of here are just all over the place. Because anytime you make a string, you just get some place in memory. Operating system says, here, have this one. The values inside don't need to be consecutive, but the list itself at like x72 is so big to store enough memory addresses for the list. Yeah, that's a good question. And it gets a little crazy. We don't care too much about this until the next class. We'll talk way more about this sort of thing if you continue on and take data science 2 or computer science 2 for data scientists. It's too long of a title. It's just too long of a title, but that's okay. So you can get values out, or you can set values with the same index notation. So you get or set using the same notation. Okay, it's kind of fun. Other things we can do with lists then. If I put a dot, so Eric's kid's name is dot, there's all sorts of things here. We're not going to use all of them here. The easy one for us to use is append. If you append something to the list, where do you think it goes? To the end. Yeah, so we append to the end. Hey, that rhymes. It was not intentional, but we append it to the end of the list. So this will add an item to the end of the list. So we could add another kid here. We've got an honorary kid. Our niece is over a lot, so we like to joke that she's one of our kids too. So she goes by Jade. Now, in age order, she wouldn't go at the end of the list because she's not younger than my baby. But again, we'll worry about that later when we get to lists. There's ways you can put things at particular locations. That's fine. We'll just throw her in at the end. So we'll add Jade. Sure. So now when I print my list here, again, if I just print the whole list here, you'll see she's been added at the end. Right? Just gets added at the end because we've appended it. Works out pretty well. All right, let's see. So we did other things you can do with lists then. Right? There's lots of cool, fun list things. You can get the length of a list if you want to know how many items are in the list here. So we can say print Eric has, and we'll just comma separate. The len is short for length. Len of Eric's kids' names, kids. So it'll count the number of values inside that list and tell me how many it has. When we run it, we see, hey, Eric has 7 kids. You don't need to count it yourself. Python's really good at counting things. Okay? It'll tell you how many items are inside your list, which is fun. So length is really handy. We'll use this a lot when it comes to lists. Okay? And one of the things, we can't do it quite yet, but we can use the length to make sure we're using a valid index here. So if you try and get at a value that doesn't exist, if you want to print Eric's kid's name, say of like the 10th item, which would be the 11th kid, there is no 11th kid here. You get index error, list index out of range, and it tells you, hey, this line right here, line 26, where you tried to get index 10 was out of range. Right? There is nothing that I can't get at that location. It's not part of the list. Doesn't allow it. And that's nice. Python is handy and useful and doesn't let you do bad things. Okay. Some other languages, I'm looking at you, C++, let you do dumb things and give bad values here. And it's really weird, but that's okay. So it stops us from doing a bad thing, right? No value here. Now, one of the weird things about lists here is I can put anything I want in the list. So this is my things to remember equals a list. And let's put something in here. Maybe I'll put a number in here. I want to remember 42. I want to remember that I need to buy some coffee. I want to remember that we need to add the lab assignment. And then I need to remember that the lab assignment is worth 10 points. And then I need to remember that, 42 divided by 7 is some particular value here. You can throw anything you want in the list. Python doesn't care because the only thing it stores inside the list is where is that value in memory. So to Python, sure, here's a memory address. Where 42 is in memory. Where's buy coffee? Where's this string in memory? Sure, somewhere else. Where's the add lab assignment in memory? Sure, somewhere else. Where's 10 in memory? Somewhere else. And they're all memory addresses. Yeah. Assignment. Yeah. See, I remember things misspelled. That's my superpower. And I'll bump that down a little bit. So you can have mixed types inside of a list. And Python doesn't care. Why is it upset here? Continuation line over indented for visual indent. Okay, it wants it to line up nicely. Then it should do it for me. That's fine. No biggie. Remember, those yellow lines are just style guideline warnings. They don't stop Python from running, but it upsets me anytime I have yellow lines, and I try and fix them because I don't like them. They're like visual clutter, and it irritates me. Yeah.
If you had a list inside a list,
Yes.
how would you index that? Would it just be back to back?
Yeah. Yeah. So if you want, then we don't get to that until we talk more about lists, but you can do silly things like a list of lists here. So it'll equal a list, and then the first thing inside of that could be another list here. So this is first item in sublist or anything you want to call that, and then you got a second item in sublist. And then we could go back and say, okay, here's my next item. So here's the second item in main list, something like that. So to get at the list of lists, the first thing is index 0. If the first thing you put in it is another list, then I would say, okay, what index do you want of that list? Sure, how about index 0 or index 1 would get us the second item in that sublist. And we could print out the list of lists at index 0 is a list. So that list's index 1 is, parentheses here. Look at that. Can I just run the selected items? The second item in the sublist. That starts to get a little more complex, and we'll get more into that later on, doing a list of lists. But yeah, you can put anything you want inside of here, because remember, a list then is just a memory address. Here's what the list is in memory. Go for it. Store that somewhere. And then if we run this in debug mode, and we looked at debug mode on Wednesday, right? We can step through and see everything executing and see things being assigned. The lists are really handy to look at. So I'm going to run it, right click and do debug here. You can see my, oops, that's right, we had an exception, sorry. I should not do that. This will crash. Crash, there is no value at index 10. There we go, one more time, run that in debug. Now, a list of something, like my things to remember, you can expand it with these little expander arrows, and I can see, hey, this is at index 0, this is at index 1, this is index 2, this is index 3, this is index 4, on and on and on. And if I step over and run the next line, I can see my list of lists. Come on, there we go. The list of lists, if I expand that now, the index 0 item is another list that you can expand. And you can see that index 0, so you can visually see a lot of these things with the debugger, which is really nice and helpful to kind of figure out, okay, what does it look like inside the system, right? We're kind of taking a peek at what it's doing in here, which is really fun. And it knows, hey, there's a string and a string, another string, and all this good stuff here. So the debugger is super helpful for trying to peek into and see what's happening. Okay, so that's some basics of lists. Let's see, so you can add two lists together, and it just smushes them together. Right, takes the first list, takes the second, like string concatenation. When you add two strings together, it just sticks them together. Same thing with lists. The min and max are really cool. So if you have a list of scores, maybe, right? So we might have some list of scores. So you folks all did really well on the very first lab here. I think everyone got all the points, but we'll pretend some people didn't do so well here. Let's see. And, so we got a couple values here, right? So the max score, or the highest score, really, right? The highest score. I don't need to go through and look at this. I can just ask Python, hey, what's the max of scores? And the lowest score, I can say, hey, Python, what's the minimum of the scores here? Hey, what's the total score? So total is not all that useful, but you can take the sum of scores. Now, where that's useful is I can get the average score then, is the sum of scores divided by the length of scores. Right? Length will tell me how many there were. The sum will add them all together here. If you add a bunch of things together, divide by how many you had, that's an average, right? Or a mean, I think is that our more technical term for it? And then we can print all these things out, if we wanted, print all of our fun stats here. So max would be the max value, or the highest score, highest, and we can print the lowest, we can print the lowest, we can print the total, I guess was silly, we'll just skip total, we'll just do average. Average score is the average score. right? So we can say, okay, the highest was 10, no surprise. The lowest was 8, no surprise. And then the average, sure. That's nice. I didn't have to calculate that myself. Right? Nice when you don't have to do the math yourself. So pretty good at doing stuff like that. Yeah.
Like, let's say you wanted like to assign a variable. Could you use the comma like you did in the print statement, or we could use the plus sign?
If I wanted to do what with line 45?
Like assign like lowest 8 to a variable.
So if I wanted to make it like a new string for the lowest score string or something, lowest score string,
Yeah, can you do the comma, or would you have to do a plus sign?
you can't do the comma because it will do something we don't expect it to do. So if I were to print lowest score string here, it's going to give us the next thing we're going to talk about, which is a tuple with this parentheses or tuple. Didn't work there. So if you want them like concatenated here, we could add them together. I think that's what you were going for. But then it says, oh, you can only concatenate strings, not int to string. It's kind of smart when we're printing, not so smart here. So to add them together like you wanted, you could say, hey, Python, please give me a string of this, right? Like we said, an int of something or a float of something, we can do the opposite and say string of something, right? Give me the string of that, and really like lowest score colon or something like that, right? Make it look a little prettier here. And now we'll get lowest score colon, right, when we printed it back out, because now we have that string value. Yep. So string lists are what is known as mutable. They're changeable. You can add to them. You can take away from them. I forgot to show you how to take things away. We could you can remove particular items if you want. So if we were to take all of your scores and then remove the lowest, I could take my scores. I can say dot remove, and I'll remove the lowest score. So that will remove the lowest score from the list. Now the problem with remove, it only removes one, the first one it finds. So it'll remove one lowest score, not all the lowest scores. And maybe that's what you want. Maybe you only want it to remove one. But you just need to be aware it's not going to remove all of the 8s. It'll only remove 1 8. So in Canvas, it's actually set up to do that. So of your quizzes and of your labs, it'll remove the lowest quiz and the lowest lab when it calculates your overall score. Right? Everyone gets a freebie, at least for those. So we could remove it from the score, and then we could recalculate the average again. Right? So then we could, this is what the new average score, something like that. The sum of the scores divided by the length of the scores. Exact same arithmetic here, but I've taken out a value. Right? So the code itself doesn't need to change. It's still doing the same thing. We don't need to like manually subtract 8 and then take length minus 1. We could do that if we wanted, right? If we knew what the lowest was, we could also calculate, this is what these, maybe the slow way average, new average score would be like the sum of the, so before we removed then, be the sum of the scores minus the lowest score. Make sure we force that order of operations, right? Otherwise you're dividing your lowest by the length, and that'd be sad. And then subtract 1 from length, order of operations again, so you don't subtract 1 from the average. You guys are good at math, right? You're going to be data scientists. You know order of operations. But just because you know it doesn't mean Python will do it. So people make mistakes all the time. It's good to be explicit. Yeah.
If there's several lowest scores, like 777, it will take one.
Yep. Yeah, it'll only take the first one that it finds. So if we were to go and print our list of scores, it would take this one out, and this one would still be there. Yep. So you could do it this way, but it's like so much nicer to remove it and just recalculate, right? But it effectively will do the same thing, right? And then we can print our new average score. And then just to show you, it should do the exact same thing. This is the slow way new average score. It should be the same value. Okay, good. I did it right. It's a good way to check your order of operations too, right? You didn't do the wrong thing and subtract 1 from your average by mistake, because people do that all the time. It's really good to check your work, right? If you, and it's a little painful sometimes to try and add those all up manually, but nice to know we didn't make any typos, because if you make some typos somewhere and then you publish it in the paper, not everyone will catch it. Believe it or not, the review process for academic papers is not foolproof. People have published bad stuff in academic papers, and that causes some bad cycle of stuff to happen. So there's one particular example I'm not remembering off the top of my head, but someone ended up publishing some pretty sketchy stuff in a medical journal, and then we based a lot of medicine off this really sketchy stuff. That's real bad. real bad. So arithmetic saves lives, friends. Arithmetic will save lives. That's the moral of that story. All right. So lists are mutable. You can change them. Tuples or tuples. I don't know the right way to say it. I think both are perfectly acceptable. Sure. Tuple or tuple, tuple. Sure. Either way, they are immutable. They cannot change. Other than that, they're just like a list. So if I were done having kids, I can make a tuple of my kids' names list, but I can't add to it or subtract from it. You don't usually subtract from it, but I couldn't add to it, that sort of thing. But we can make a tuple then of scores. So maybe I have the final scores then will be a tuple. So tuples use parentheses instead of square braces. That's the only difference for when we're creating a tuple. Now I need to give it all the values. So when you take your final or present your final project, we'll have a bunch of scores. Hopefully you all get 100. Like nothing makes me happier than everyone being successful on the final project. I promise. Like I'm just thrilled when people do well on the final project. You have like 4 weeks to do it, and people still don't do well on it occasionally. And I ask them like, well, what's going on? Why didn't you tell me you were having trouble? They're like, oh, I don't know. Okay. If you don't tell me it's not working for you, I'm not a mind reader. Like, it's not going to go well for you. So, tell me, right? If something's not going well, because otherwise, I don't know. Like, I'm happy to help. I'm not. I come off kind of mean, I guess, with the grading policies, but like, I will point you in the right direction. I'm not going to solve it for you on your projects, but I'll point you in the right direction because it's easy to get stuck on these things, and you get in your head and you're like, okay, I need to do this, but I don't know how to do that, or I need to do this and it's not working, or I get some error message. My general rule of thumb is you should probably spend a good half hour to an hour trying to figure it out yourself. And it's a little frustrating, but there's some value in that process of being frustrated and trying to find a solution and work through it yourself and figure it out yourself. Don't come ask me after like 2 minutes. Like, I got an error. Eric, what does it mean? See if you can figure it out, right? Have we seen it before? Google sometimes is not all that helpful for like intro classes because the stuff you find on Google is like up here and we're like down here still. But try it. Try and see if you can figure it out. After half an hour to an hour, just come ask me. It's not worth you getting frustrated at the assignment, frustrated at the class, frustrated at me for giving you this terrible assignment when pretty much all the time it's like a 5-minute fix for me. I'll look at your code, I'll see what's happening, we can do a screen share, and I'll say, oh, that's where you went wrong. And then you feel much better, and I feel much better, and you're making progress, and we feel like you're learning. So, a good half hour to an hour of frustration is okay. Someone came to me, they're like, I've been spending 8 hours on this, and I don't know what's going on. Like, they were pissed off because they've wasted an entire day not going anywhere before they contacted me. I'm like, oh, you got an extra comma here. It was literally an extra comma. Like, that was it. And then they were like even more mad that it was just a stupid comma stopping everything from working. It's not healthy, right? And that's okay. So especially when you get into the workforce, you're going to have to do work and do stuff for your job. If you just sit there and get frustrated at it and you don't get anything done, it looks bad for you. And then you're frustrated and then you feel bad about yourself. You're like, oh, I don't know what I'm doing. I shouldn't be here. And it doesn't go well. Like, no one expects junior programmers to know everything. We know you're new. That's no surprise to people that you work with that you're new and you don't know all the answers. Nobody knows all the answers, right? No one can keep it all in their head. Like, it's impossible for one person to know everything. Some people try, but and some people know a lot of stuff and they have a lot of experience, but you just don't know. So the best thing you can do is ask questions. Again, try. Like, okay, I've tried this. I looked at this. And go through that process of these are the things I've looked at. This is what I've looked. This is what I've thought about, and that also helps them. Someone who's more experienced know what it's not. Then, all right, you already looked at this. Okay, it's not that. It's not this. It's not this. And then maybe they'll know what the problem is. So again, a little bit of effort, right? But then come and ask. And I'm happy to help point you in the right direction. I don't feel good making people waste an entire day. I don't enjoy that. I don't know. Some people might, because academia is a weird place and people have weird reasons for getting into academia, but that's not me. Okay. Anyway, so there's 2 bullet final scores then, right? So we're doing really well on the project here, and a bunch of people are getting hundreds, and that makes me happy. And I don't know, sure, that's good. We can do all these same things that we did here with the min, the max, the sum, the average of final scores here. Works all the same way. You can get at the first score. So I can print the first score, or first final score is my final scores, index of 0. Now you still use the square braces for index, even with the tuple. It might be nice if it was a parentheses, but it's not. It's still the square braces. So you can still get the values out. But what you can't do is you can't set a value. I can't say final scores is 90. Now, it's going to look like it'll work here. Python's not going to tell me anything's wrong until I go and run it. I'll get a tuple object does not support item assignment. You can't assign a value to a tuple, to an individual item of a tuple. Not allowed. Tuples are immutable. They are not changeable. You can't add to it. You can't subtract from it. Once you make your tuple, it's stuck. Okay, we'll look at a little later on. This is not entirely true, but that has to do with memory addresses and what it stores. So you can't change the memory address that it stores, is the technical answer here. Okay, I can change what's in memory at that location later if I wanted to, but I can't change it inside the tuple. The tuple will always point to this thing in memory, and that'll matter more later. Okay, so you can't change things. Essentially, you can't change individual values, right? Otherwise, that'll crash. No good here. Individual values. That's no good. So we got lists. We've got tuples. Okay. So if you want it to be changeable, use the list. If you don't want it to be changeable, use the tuple. On that, they do the same thing. Order still matters. You still have the first thing. You still have the second thing. You still have the third thing. You have index starts at 0, goes up to. So the last index is always the length minus 1. Right? If there's 7 items in here, I don't have an index 7 because I started counting at 0. I have an index 7 minus 1. If I have 20 items, I don't have an index 20. I have 19. It's the last index. So it's always your length minus 1. Okay. Cool. Cool. All right, so that's some list basics, accessing each one, updating values, great. Yeah, adding, you can remove values. So this pop in a list here will remove something at an index. So my things to remember .pop, if I don't put anything in here, we'll remove the last thing. Or I can take my things to remember and I can pop, hey, I want to remove, how about the 0th index? That index. We'll get more into this later. Just know it exists. I'm not going to ask you to do anything like that right now. But you can remove the last thing, or you can remove the first thing, or anything in between. Right? Whatever index you give it, great. We'll go remove the item at that index. Everything then will shift. You can't have nothing at 0. So what used to be 1 now becomes 0. Right? Just like if you were to erase your to-do list on your piece of paper, now you have the new first thing at index 0. And we'll talk more about that later when we get into lists. So you can add things or remove things. So if we look at this things to remember in debug mode, here's my things to remember. I have 0, 1, 2, 3, and 4. When I call pop, I'm going to lose the 6.0. Right? It's gone. No longer there. Now I just have 0, 1, 2, and 3. When I pop the index 0 off, I'm going to lose the 42, and everything else will shift down 1. So now I have 0, 1, and 2. Used to be the old 1, 2, and 3. Right? Because I have to have something at 0. So you're always going to have the 0th item. And you can kind of see what's happening there. All right, so that is lists and tuples. Let's go back here. Sets are fun. So a set is a collection of unique items here. So with a set, remember, you can't have duplicates. So in the class here, we have a set of students. There's no duplicate students. Sure. That's probably not a great example because you're not going to try and take the same class twice. That wouldn't work out very well for you. But if you wanted to make sure you only had a unique set of something, we could use that set value. So the notation for it's a little funny here. So here's like unique numbers, then you say a set of something, and usually we might give it some sort of list here, like 1, 2, 3, 4, 5, 6. Sure. Now we have a set of something. You can do some fun stuff. Now, when I hit dot, I get access to all the cool things that sets know how to do. Sets can do differences, they can do intersections, they can do unions. I don't know when you get into that in math class, I forget. Right? But the difference between two sets, what's in this set that's not in this set, or the union of the sets, let's add them all together, what are all the unique items, those sorts of things. I forget when you do that in math class. But this might become interesting then. Right? You can add a particular item to a set, right? You can add things to it here. So if we try and add a 4, and it already exists. Sure. Right. Unique numbers. Let's print it before and after, right? So we'll just print our set here. Looks the same. Notice with the set we get curly braces. Always different notation. So the list was square braces, the tuples were parentheses, the set is curly braces. Hey, Aiden, my friend, thanks for dropping on by on Twitch. Didn't do anything because it wasn't unique. Okay, sure, not a problem. If I want to take my unique numbers, I want to add, say, a 42. That should probably do something then, right? Now it adds 42. Now, an interesting thing with sets is the order is not guaranteed, right? I can't always get out the first thing won't always be the first thing. So sets are really an unordered collection here. So sets are an unordered collection of unique items. Most of the time when we work with them, they'll look like the order is maintained if you want to add things or remove things, but it's not guaranteed. Eventually it will change. We do more of that in the next class. Look at how we can play with some of these things and make them work like that. So, but unordered set here, collection of items. You can make sets. You can modify sets. You can add things. You can remove things, pop things out. Pop will just do a random item out. Yeah, some fun stuff with sets. Yeah, differences, unions, intersects. Symmetric differences, sure, that probably means something. That's probably enough for set basics for now. Again, we can do more with them later. Just want to throw out a bunch of different types and see what sticks. And this is like, here's all the fun things we can do with Python, and then we'll come back later and look more of these in detail later as we go. So just know they exist. We'll play with them. Maybe in this lab, maybe we'll do some of the basics in this lab. We'll see how far we get. So you guys are doing great. The next main type that we use here in Python is called a dictionary. And a dictionary works a lot like you might imagine an actual dictionary is. You get some collection of unique values, like words, and you get the definition or the associated value with that word. So here's some value here, and here's the meaning of it. Here's an associated value for it. So we're pairing, here's what we'll call a key, here's the associated value. So in an English dictionary, the key is the word, and the associated value is the definition of the word. You are not going to have the same word in your dictionary twice, right? You might have multiple definitions, but it's the same word. You're only going to have that definition once. So the dictionary has a unique set of keys with associated values. And to make a dictionary, we use curly braces. These curly braces, just like we saw with sets. So this is, maybe we have names and scores here. So we use curly braces. Now the notation here is funny. It's okay. Just look it up every time you get used to it. So if we start giving some scores to people here, so we'll give a score to Alan. So name, colon, score, comma. So you get a pair. You get a key and an associated value. So it's key, colon, associated value. So the value associated with that key. Right, so they're always used in a pair. And then we can add Bob has a colon score of 90, comma, Carrie has a score of 80. Don colon has a score of 100. these key comma values, and it doesn't like the spaces. I like spaces. I don't know why I hate spaces so much. That's okay. So we get keys and associated values. So if I were to print names and scores here, we get basically what we put in. It prints right back out what it looks like. Name, colon, value, name, colon, value, name, colon, value. Right, here's the key, here's the associated value. Now, dictionaries don't have a guaranteed order, same as sets, right? We get a unique collection of keys, but there's no guaranteed order. So I can't say, give me the first thing in a dictionary. There is no concept of first thing in the dictionary. If I wanted to, I could take all the keys out and sort them in some sort of manner and take the first one in a sorted order. Like, hey, I put them in alphabetically, sure. Maybe I want it alphabetical, but by default, it just doesn't do that for you. And again, we're not going to see it for now. They'll all kind of fit in order. Eventually, they won't, and then the order will jumble itself up. But for now, it's fine. So when you use a dictionary, we use some crazy notation. And this is going to be rough for a while, but we'll figure it out eventually. Don't worry too much about it. So if I wanted to print, so this is Alan's score is, oops, I should do this in double quotes, right? I'm going to use a quote or an apostrophe in there. So to get the value of Alan's score out of the dictionary, I say names and scores, and then I say index of, well, it's not really index of. Now with the dictionary, it's key of, quote, Alan. So we read this as key of, right, with the square base notation. So find the value associated with the key of Alan, right? Value associated with the key of. So the key of Alan will get the value associated with Alan. Now, it's not going to give me Alan. It's going to give me the value associated with Alan here. If I just want the value Alan, then I already have the value Alan. Like I literally typed it in. I don't need to ask the dictionary for that because I just typed it, right? So we can run that one, and we'll get the value associated with Alan is 100. That's his score. Okay. If you want to change Alan's score, we could say I names and scores key of Alan, assign it a new value. So similar to lists, you can get the value and you can set the value, but what we're getting and setting is the value associated with that key. So we can say, oh, Alan, you didn't do so well. We went back and reviewed it. You only got a 95. And now we print Alan's score is, and we should get out a 95 because we've changed the value associated with Alan. The key of Alan hasn't changed. It's still Alan. Alan's still the key. If you want to completely remove Alan from the dictionary, we would pop Alan. Pretty sure. This one always confuses me. There's like, they use the same pop for lots of different things. There we go. Yep. So you can remove the key value pair with pop, right? Where pop in a list removed something at that index or the last thing, or you can remove something by value, we pop by value. And this is why it's confusing, because like none of them match. And that's okay. Like I'm still confused by it. Okay. So don't feel bad if you're confused by it, please, because you just have to go look it up sometimes. It's not worth remembering. Like when you do it often enough, it'll be in your head, and great, you'll have it memorized. But just look it up a bunch. Like the zyBooks has these nice little tables here of like, here's all the things you can do. Like where'd it go? It's not. Why does it not have it? Oh my goodness. It shows delete. I hate this delete notation. Delete is obnoxious. I prefer pop. But maybe delete makes more sense then. Maybe that's why they don't show you pop, because pop's confusing. And just this is more programmatic, a more conventional programming way of doing it. The delete keyword is just ugly, but sure. So if you wanted to add something to the dictionary here, right? This is setting the score of Alan. If we wanted to add a score here, we use this exact same notation. It's crazy. So if we wanted to add someone's score, add a score for a key of, we'd say, hey, names and scores key of Eric, and we'll say Eric definitely gets 100 because it's his class. This is really an add/update. If it does exist, it updates. If it doesn't exist, it adds. right? The key exists, it updates. The key doesn't exist, it adds. So the same notation for add or update is fun. Right? And then we can print out names and scores, and we'll see now Eric has 100 in the class. Right? Or 100 on yeah, it's just names and scores. So probably 100 in the class using that exact same notation. That's a dictionary. So key and associated value, key and associated value, which is kind of fun. So it's a good way of storing things that go together. Right? If I wanted to have names and scores otherwise, I could, if I wanted, right? I could have a names list here. Is what do we have? We have Bob, Carrie, Don, and Eric. Bob, Carrie, Don, and Eric. And I could have a scores list of the Bob 90, 80, 100, 100. 90, 80, 100, 100. I could do it like this, and I could get the value out of names, and I could get the value out of scores, and as long as the first thing matches the first thing in the other one, we could. This would totally work, right? In terms of getting something done, this is functional. It's a little bit obnoxious and probably more work to try and manage to make sure that they stay in sync here. So if you go and remove Bob, we have to remove the first thing over here. Or if you remove Eric, you have to remove the fourth thing over here. It's doable. It's just annoying, right? So if I were to take names and I wanted to remove Eric, well, do I know what position Eric's in? Because then I'd have to remove something at a given index. I'd have to go pop the third thing off, which is the third index, which is actually the fourth thing, right? And this is kind of annoying, right? There's ways to do it. We'll get more into some of those fun things later, but it's harder to keep things in sync like that. If the data makes sense to be paired, this associated with this value, great. We like it. It just works. Works out pretty well.
Does it matter what type of data I put into the dictionary? Could I put assign Bob failed a string instead of the score not?
Yeah, definitely. So we can say names and scores key of Bob. Let me do this at the end here. Sorry. Names and scores key of Bob equals failed. Sure. And then we could print our names and scores. We could also say, hey, my names and scores key of 100 equals Eric. Python could care less. Sure, you now have a key of 100. The associated value is a string. You can mix and match to your heart's content. So now we get Bob failed, Eric has 100, 100 has Eric. Sure. Maybe I want to make a list of scores, and the associated value could be a list of students' names with that score. That's a really weird way to store scores, but sure, right? Or here's the value of A for the grade. Here's a list of everyone who has an A. Go for it. It's your dictionary, your way of storing your data, whatever makes sense to you. Now, some things are harder to work with than other things, but sure, go for it. We can do all sorts of fun stuff like that. So this idea then of being able to use these, this is not very interesting when I've hard-coded everything, right? Because I know what all the values are, but if I'm working with the user to say, hey, enter some values here, right? I'm going to be dealing with variable data, whatever the user types in. Sure, we can go for it. So I can say, okay, enter the names of your students, enter 10 students' names, enter 10 students' scores. Go for it. We can do that sort of thing. So let's do that. So let's have a, this is, I don't know, custom, from user names and scores equals an empty dictionary. So just curly brace, opening curly brace, closing curly brace. Sure, it's empty, and then I can start asking the user. So we'll say, we'll get a name is equal to an input of the first student's name, and then I need to get their score is going to be an int of an input of enter the first student's score, or really, then we could just take name too, which is kind of nice. So instead of first student, now inside of an input, you can't do comma separating. I can't say name and score like this. I think we can. Does that work? I don't think it worked. Eric, yeah. No, it doesn't work here. So we need to do the concatenation. So I would have to take that plus name plus score. But this will look a little nicer, right? And I can say, okay, now enter Eric's score. Enter the Eric score. Oh, enter, how about apostrophe S's score? There we go. That'll look a little prettier here. And then we'll get Eric and enter Eric's score. 100, sure. Okay, so now that it looks a little prettier here, I can take my from the users names and scores, key of the name, associated value of the score. This will add or update. So the problem is if there's more than one Eric in the class, which used to be a lot more common when I was a kid, like there were 3 Erics just in my neighborhood, not to mention the entire school. So you can imagine this was a problem for me a lot. So hopefully they're going to put in their student's full name, because I've never met another Eric Chinesky in my life. I probably never will. I think the name's kind of gone out of style, and it's either up to my nephew or my cousin to have a kid and name them Eric after me, which probably won't happen either. But maybe in a couple of generations there'll be another Eric Chinesky, and at that point I won't care. So, but if you put a unique first and last name, this will work. If you have 2 students with the same first and last name, who was it here? I went to school with, what was his name? Something Smith. What was his first name? It was a real common first name. I don't remember what it was, but his last name was Smith. Like, poor kid. Like, you're gonna have all sorts of name collisions. It's not great. That's why you folks all have a student ID number that is system generated, that is unique to you. So when we reference students, if I go look in Canvas, I get student ID numbers and names. And if there's more than one Bob Smith here, then great, I'll see, okay, this is student ID number 123 Bob Smith, this is student ID number 456 Bob Smith, and I can tell them apart. Honestly, I probably can't, but Canvas will keep you separate here, which is nice. So we can add some names and scores. So I can just repeat this over and over and over as many times as I want here. And we'll do first, second, third, and fourth student's name. And then I can just print my from users names and scores dictionary here. So we'll add some students. So we'll have, we had what? Alan had 100, we had Bob had 90, we had Carrie had 80, and then we had Don had 100. And we see we've now generated from the user. Excuse me. Okay, works out great. The problem, though, is if I'm expecting to do some sort of arithmetic here, like if I wanted to go get the average score, I could out of dictionary. It's just going to take a little bit of time to go through it. I don't even really have all the names, but there's ways we can do this with dictionaries. Does this? I don't think we get into it with the basics. So when we get to the dictionaries chapter, we'll look at ways like, hey, I can go get the average score out here because I just need the values associated. I don't need all the keys or how to go through all of those. We'll get to all that stuff in a little while. But we could go generate an average if we wanted, eventually. I guess we could do it now, but we'd have to work off the score each time. That's probably no fun. But we could get that. But because I'm just taking user input here, if they said, hey, first student's name is Eric, score is passing, oop, we're going to crash because it doesn't convert to an integer. Okay, so at least we're checking to make sure we get integers here, which is nice. Because we're dealing with then integer values rather than string values. Because it lets you mix and match, like we saw. You can put anything you want in. You have 100 here. Where did we mess with that? We had right in here. The key of 100, then its value is Eric. Like, if you try and loop through all the values associated with the keys and you get a string here, it's going to mess up your arithmetic. Bless you. So, but it's up to you for how you put the data in, and whether or not we need to check to make sure it went in the right way, that sort of thing. All right, so we're about through here. Now let's look at this summary, and then we'll get to some of this other stuff Wednesday. So with the summary, right, our numeric types, ints and floats, are sequence types where the order matters. Strings are technically sequence types. It's just a bunch of characters. So with a string here, then, I don't know if we actually looked at this or not. So if I have my name, then is Eric Chinesky. The first letter is my name, index of 0. Right? This is a sequence type. The order matters here in this string of characters. This is a single character. So I can get out just that first line. Wrong button, my mouse. There we go. So same idea. I could get the length of my name here. Right? So I could print your name has length of name characters. Now, the problem is it's also going to count the space because the space is technically a character. So it's going to say 15 instead of, no, it's going to say 14 instead of 13, right? Because Chernesky has 9. No, yeah, it's 9. It's 9. I probably should know that. Eric, oh, okay. Yeah, we don't want to do all that. Let's just run the selected. There we go. 14 characters instead of 13 because we counted spaces. But again, that's okay. But you can do all the same stuff. The max letter is the max of my name. The min letter is the min of my name. Average is no good here, but let's see if we can get max and min. Oh, we never printed them, sorry. There they go, in the little debugger here. Max letter was Y, the minimum letter was the space. Remember we looked at individual characters that had those ordinal values or the Unicode values? The smallest Unicode value is now the minimum letter. So the space comes before all the letters. This capital A was, I think, 65 for capital A. Is that right? Don't memorize that stuff. It's not worth having in your head. But then lowercase letters came after the uppercase letters in the Unicode table. So the lowercase letters are greater than the uppercase letters because why would we compare min and max of letters? But sure, we can do that. So you can do all the same things with a list because it's a sequence type. Strings, lists, and tuples are sequence types. Order matters. Mapping type is the dictionary type. And then you also have the set. Unique elements, mutable. It's not a sequence type. It's not a mapping type. It's just a set here. Yep, awesome. So we did pretty good, folks. So we've got a little more to cover on Wednesday, and then we'll talk about the very first project. Is that a question?
Yes. So you know how it said the minimum letter was like the space?
Mm-hmm.
How do I determine that? So like if somebody calls and said O'Connor with like an apostrophe, then how would they determine that the space?
So it would look up this Unicode table, or take the ordinal value of each letter, like we looked at, and whichever one has the lowest ordinal value. Here, so the apostrophe looks like is going to be a 39, and then the space looks like it's a 32. So whatever has the lowest numeric value that we're using to store, because when you store a character, it actually stores a numeric value in memory. And then when you want the character back out, it knows you actually want it as a character and converts it for you. So it's just how we store all of our letters. And you can get all the fun accented characters as well. So that's how we actually store these. Is they're not the usual ones. They're a little higher in the Unicode table. Yeah, sure. Use cookies. Do you ever see that silly meme? I love memes. You should post them in the memes channel on my Discord because they make me happy. Where they're like, this website uses cookies. Click yes to accept to share your cookies, and the Cookie Monster it shows up and he's like, "You fool!" and he's all sad. Share your cookies. My younger son, my 8-year-old, loves Sesame Street, and it's on like all the time. So I know a lot of the Sesame Street episodes. It's the sort of stuff that shouldn't be in my head. All right, so I think we're pretty good for today. We've got lab in another 20 minutes or so over in the HPEC building. I'll see you over there, and we'll practice some of this stuff. Thanks for coming online, folks. Hey, Blowfish, thanks for dropping on by. Yes, Ernestinence. I'll get your name right one of these days. The cookie meme is fantastic. Yeah, drop by the Discord, post some memes for me, chat with the rest of the class if you want. It's all like self-assigned roles, so it's a lot of fun.